Chapter 25, Comparing Counts. Checking the conditions. So for counts we have three tests: goodness of fit, homogeneity, and independence. We're going to start by looking at the conditions of these individually. Goodness of fit. We have degrees of freedom, which is the number of cells minus 1. Our first condition is that our data are counts. So we just check, is each cell a count? Data in the samples are independent. So an SRS or representative sample, as usual, and that we have less than 10% of the population. To verify the sample is large enough, we want to make sure that all the expected counts in each cell are at least 5. So this isn't the numbers that are there, the actual counts. This is what we would expect if everything was distributed evenly. For homogeneity, our degrees of freedom are the number of rows we have, minus 1, times the number of columns we have, minus 1. To check our assumption that data are counts, we just verify that we have counts of data in each cell. Did we count total values up? Okay, again, the data in the groups are independent. We need to verify that it came from a simple random sample, that randomness was involved, or that it's a representative sample. As usual, we also need to verify that our sample is less than 10% of the total population. Groups are sufficiently large. As in a goodness of fit test, we just verify that all expected counts are at least 5. The expected value of the cell counts, not the actual value from our data. Lastly, we have the test for independence. Again, our degrees of freedom are R minus 1 times C minus 1, the rows minus 1 times columns minus 1. Counts, we just verify that we have counts of data. Data are counts assumption. We verify that our cells all include just counts. Data in the sample are independent. Again, simple random sample or a representative sample. And we also must verify that our sample size is less than 10% of the population. Finally, to check the assumption that the sample is sufficiently large, as in the previous two, we're going to verify that all expected counts are at least 5. Again, we're talking about the expected values if everything was distributed evenly, not the actual counts that we have.